exclusive prices. Download the free Booking.com app today. Exclusive prices. Download the free Booking.com app today. Exclusive prices.
Check one. 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 check 1. Right, good evening everybody. Today is the day 1 of Geometrical Optics interactive class. So we're going to start a new kind of a class. Even though it's new experience for y'all, this has been done for the previous batches as well. So I usually start an interactive class other than a normal live classroom, live stream. So this is the day 1 of the online interactive class, right? Today you will join and see. During the class you will understand how the class proceeds. You will understand how class is going to proceed. Hurry. So today is a free class. We are going to start the geometrical optics lesson. That is the 5th lesson, and you will see how the class is going to proceed. Before we start, confirm me from your end. Can you all see the board clearly and hear the audio also clearly? Is video, audio, everything clear? Yes, Zoom is clear. I'll check with YouTube. Harine, YouTube audio. Zoom is clear, yes. Yes. YouTube still I don't get the confirmation. Now clear. Previously there was an echo. Harine.
Zoom is clear, yes.
Yes. Hurry, right.
Yes.
YouTube still I don't get the confirmation. Hurry, right. So regarding the class will proceed on Saturday like this from 8 o'clock to 10:30. 10:30 is the time that I have given, but maybe it will go until 10:45 or maybe it will run until 11 o'clock. It might go, right? Depending on the lesson we are doing, depending on the amount of work we have to finish. So it's timed as 10:30, maybe it will go until 10:45 or maybe it will go until 11, right? So that's the normal timing. Plus today is free class. After that, if you want to join the class, after today if you want to join the class continuously, you can send a message to the where is the number? You can send a message, WhatsApp message to note 286 7229. This is our admin number. Any messages, any class regarding inquiries, you can contact this number during the working hours. You can contact these numbers and you can get the information. Those are the details I want to tell. Additionally, I already posted you all the tute. I hope you all are ready with the tute. Already by about Wednesday I posted the tute. I hope all of you are ready with the tute. At least have the PDF for now. There are some writing parts you can write in a writing book. So you all have joined the class today, no? So at least have the PDF now. I have already posted in our WhatsApp channel. Check the channel, all the links together. At the end I have posted the tute link, so you can check the tute as well. Have the tute also nearby because we'll be proceeding with the tute. Right. Ehenang lamai, we'll start the class. Right. New lesson. This is your 5th lesson in grade 11. This is the 5th lesson in grade 11. That is geometrical optics. Geometrical optics. This is your Unit number 5. Unit 5, geometrical optics. What we learn in geometrical optics? I'll first tell with the heading itself. Geometrical optics. Geometrical optics. Lamai, what do you mean by optics? Optics means something connected to the light. Optics means something connected to the light. Light is optics. Optical instrument. Instrument that deal with the light. And also optics means something connected to the light. Now even the spectacles, we use the word optics there. Optical shop. We go to optical shop to buy spectacle because spectacle also deals with the light. So optics means connected with light. Geometrical. Geometrical means, now in maths, you would have learnt about geometry. What do you learn in geometry in the maths there? What is maths geometry? What they tell in maths geometry? Maths geometry talks about constructions. Neither. They ask you to draw a circle, draw a line that touches the circle but doesn't touch the circle. Draw a triangle which is inside the circle but outside the circle. That is geometry in maths. No, that is geometry. So constructions is geometry. Now in this lesson, we are going to learn about light using some constructions. Using constructions, we are going to learn about light. We are going to learn about the behavior of light using some constructions. That is the base of this lesson. So before starting this lesson, we'll revise on some important things that you already know about light. This you already know, but I wanted to revise before I start. Point number 1. Luminous object. Luminous object. What is luminous object? Grade 6 work. What is luminous objects? Objects that can emit their own light. Luminous object. What is luminous object? Objects that can emit their own light. They can emit their own light. They can emit their own light. Objects that can emit their own light are luminous objects. They emit their own light. They emit their own light. Ehena, y'all tell me some luminous object. Now I'm going to allow you to unmute. You are going to unmute and talk to me. Those who can unmute and talk to me. I'm going to allow that feature. Now that's the importance about this interactive class. You are going to talk and we are going to discuss and do the class. That's how the class is going to proceed. Alright. Go tell me some luminous objects. Sun. Moon, I'll talk about moon separately. We'll keep moon separately for now. Tell me some other. Candle, lighted candle. I'll write one by one. Lighted candle. Stars, very good. Stars. Lighted bulb. Firefly. Light emitting mushroom. Those are all luminous objects. Now you can mute yourself. Those are all luminous objects. They can emit their own light. The opposite is non-luminous object. The opposite is non-luminous object. Then what is non-luminous objects? Objects that can't emit their own light. Objects that can't emit their own light. Objects that can't produce their own light. They do not emit. I'll put a cross sign, right? They do not emit their own light. They do not emit their own light. What are the example things that cannot emit light? Now, for example, I can tell a table do not emit light. Yes, sir. I'm not a luminous object. No. I can't emit light. No, so, yes, sir. Moon. Moon is luminous, non-luminous. Remember, moon is a non-luminous object. No, sir. Moon can emit light. No. Lamai. Moon does not emit its own light. Moon reflects the light falling from the sun. What does the moon do? It reflects the light falling from the sun. So I didn't tell object that reflect light is luminous. Object that emit their own light is luminous. Sun emit their own light. Star emit their own light. Actually, stars are what? Sun. The different suns in different Solar systems are the stars. The stars, sun, they emit their own light, but moon, it does not emit its own light. It has become luminous because it reflects the light. That means it's not actually luminous, it is non-luminous object. So these are some basic things. Other than that, materials depending on the ability to transmit light through them, we can divide them into three. What are the three? Transparent object or transparent material, opaque material, opaque objects, and translucent object, translucent material. So material based on the ability to transfer light through them, you divide them into three: transparent, opaque, translucent. First going to transparent. What is transparent? Materials that allows the light to pass through. Grade 6 work lamai. Tell me some transparent objects. Poly. But if you be specific, you can tell colorless polythene. So I'll write polythene, but if you be specific, you can write colorless polythene. Right? Polythene, transparent glass, right. Water, colorless water, pure water. Those all transparent materials. Opaque. What is opaque? Materials that do not allow the light to pass through. Tell me some example. Cardboard. Sheet, white sheet or A4 sheet. Stones, right? Wood, blackboard, all are opaque object. Translucent kiyanne, this is how you define translucent lamai. Some materials allow the light to pass through, but light goes in different directions, which means light gets scattered when it goes through those materials. Light changes the direction and goes to different directions. When it goes through those materials. What are the examples? Now, for example, oil paper. If you take oil paper, through oil paper you can see the light, but can you clearly see the light? No, you can't clearly see the light. That's because light get scattered when it goes through the oil paper. So oil paper or tissue paper, those are translucent. Hurry, those are some basics. Right. Now take the tute. In case if you don't have the tute, use the PDF for now. Geometrical optics. Objects that emit light are luminous object. Example, candle flame, light bulb, sun. Objects that do not emit light are non-luminous object. Example, your sir, table, moon. Objects through which light passes through are transparent object. Example, glass and polythene. Objects through which light do not pass through are opaque object. Example, brick, stone. Light passes through some material with irregular changes of the direction, making it possible to see the object on the other side clearly. Making it impossible to see the object on the other side clearly. Such materials are known as translucent material. Example, tissue, paper, oil, paper. Alright. Those are some basics. Next, listen, we are slowly going deeper into this optics section. Now, some geometrical drawings you need to know to start this lesson. What? Listen. Light ray. What is a light ray? A single ray of light is a light ray. Understand this definition. A single ray of light is a light ray. How do you represent a light ray? You use a straight line and you show the direction of the light ray using a arrowhead. That's the light ray. Next, light beam. Light beam. What is light beam? A collection of several light rays together is a light beam. A collection of several light rays together is a light beam. Collection of several light rays together. I'll draw several light rays. 1, 2, 3, and 4. Collection of several light rays together. This is a light beam. This is a light beam. Now look at this light beam. Can you see all the light rays, they are parallel to each other? All the light rays, they are parallel to each other. Then you call it parallel light beam. Parallel light beam or parallel beam of light. Next, convergent beam. What is convergent beam? If all the light rays come and meet at a single point. If light rays come and meet at a single point, you call it a convergent beam. I will draw it and show. I will draw it and show.
Excuse me, sir.
Yeah, Buddha. If all the light rays come and meet at a single point, you call it a convergent beam. See, all the light rays are coming and meeting at a single point. Convergent. Next, divergent beam. What is divergent beam? If all the light rays spread away from a single point and go. If all the light rays spread away from a single point and go, you call it divergent. If all the light rays spread, see, they are spreading. If they all spread from a single point and go, you call it divergent. Understand the difference between convergent and divergent. Convergent, all the light rays are coming to a single point. Divergent, all the light rays are going away from a single point. Someone's mic is on mute. Convergent, all the light rays are coming to a single point. Divergent, all the light rays are going away from a single point. Sorry? Sorry. Right. Now, in the tute, important graphical representation. Light ray, parallel light beam, convergent light beam, divergent light beam. I want you all to draw them. Now, in case if you don't have the tute, no problem. At least in a writing book, write this, write and draw these things and keep. Maybe online people won't hear what the students talk here in the Zoom, because I am not streaming Zoom, I am directly streaming my videos on. So online people, I mean YouTube people, won't hear directly what is talked in the Zoom class. What the students are talking, you might not hear.
Sir, can you give examples for convergent and
We will talk. Don't worry. These are just basics. Don't worry. We are going to talk about convergent beam. Maybe under lenses we are going to talk. We are going to talk about divergent beam. Under lenses we are going to talk. Once done, send me a message. Done. Okay.
That's that's
Okay, no? So those are some important graphical representation that you should know before starting this section. Right. Now, in this lesson, what we are going to learn about, we are going to learn about the behavior of light. We are going to learn about the behavior of light using some geometry. Remember, light shows two behaviors. Light shows two behaviors. What are the two behaviors that light shows? One, reflection, and two, refraction. Light shows two behaviors, reflection and refraction. Those are the two behaviors we are going to discuss in this lesson. First, starting with reflection. Starting with, there you go, reflection. What is reflection? What is reflection? Simply put these things into your mind. What is reflection? Bouncing of the light when light falls on a smooth surface and returning to the same medium is reflection. What is reflection? Bouncing of light on. I will draw and show. Bouncing of light. Bouncing of light. Bouncing of light. Light is coming. It is bouncing. Light is coming. It is bouncing. Bouncing of light. Bouncing of light after falling on a smooth surface. This is the smooth surface. This is the smooth surface, or you can call it a reflecting surface. It's a smooth surface, or you call it a reflecting surface. So light falls on the smooth surface, it falls on the reflecting surface, it bounces and goes back to the same medium. What I mean by same medium? It is coming in air medium now, it bounces and again go to the air medium. It comes in air medium, it again goes to the air medium, that is reflection. It's coming, it's going to water, no, it's coming in air, it's going to water, no, that is not reflection. There something else will happen. I'll talk about it later. So here it bounces and goes back to the same medium, that is reflection. So if light comes through air, it bounces and again it should go back to air. It should again go back to air. That is reflection. Right? There are some important points you need to know about reflection. Someone's mic is on mute. The light ray that is coming, is called as the incident ray. Read with me, open the mouth and tell louder. You're in your house, I know, tell louder. When we are teaching, tell louder so that it goes into your mind. The light ray that is coming is incident ray. The light ray that reflects and goes, is reflected ray. That is the incident ray, that is the reflected ray. And the point where incident ray meets the reflecting surface. The point where incident ray meets the reflecting surface is called point of incident. Point of incident. The point where the incident ray meets the reflecting surface is point of incident. So this is the point where incident ray is meeting the reflecting surface. That is point of incident. Next, at the point of incident, you draw a dotted line. Like that. At the point of incident, you draw a dotted line like that. That dotted line should be perpendicular to the reflecting surface. That dotted line should be perpendicular. You all tell me, what do you mean by perpendicular? What is the angle? 90 degrees. Perpendicular means 90 degrees angle. 90 degrees angle is perpendicular. So you draw a dotted line perpendicular to the reflecting surface. Where? At the point of incident. You draw a dotted line perpendicular to the reflecting surface at the point of incident. That dotted line is called as normal line. So remember, normal line should be drawn perpendicular to the reflecting surface at the point of incident. Is this line really existing line? No, it's an imaginary line. What do we mean by imaginary? In this lesson, so many places we come across the word imaginary. The word imaginary means it's not really existing. It's something that we imagine, maybe for the analysis, maybe for the analysis or mathematical analysis or for scientific analysis, we imagine. So do we really have this line? No, we don't really have this line. It's an imaginary line. It's an imaginary line. Imaginary lines are not really existing. Let's say you take a laser light, point the laser light towards a mirror, it will bounce and go. It will reflect and go. Will you see an additional dotted line at the center there? Will you really see a dotted line at the center there? No. You won't see any dotted line at the center, no? It's something imaginary line we drew. For what? For our studies. It's an imaginary line. Another example. In geography, you would have learnt about equator. Wait, I'll come to the doubts. In geography, you would have learnt about equator. What is equator? It's the central line, that horizontal line that cuts the earth into two halves. Equator line. That is a real existing line, then nothing imaginary line. That's an imaginary line. If it is really existing, we should be able to see. They tell Sri Lanka is near equator. Go look at the sky. Can you see the equator line? No. So it's an imaginary line. So those are imaginary lines. This is an imaginary line. You don't really see it. Remember, in geometrical optics, for any imaginary line, you use dotted lines. Again, I repeat, for any imaginary line, not only normal line, any imaginary line, any non-existing line, we represent it by dotted line. Keep that in mind. That's very important in geometrical optics. Anywhere, if something is imaginary, we use dotted line. If we use normal solid line means really existing line. So incident ray is really existing. Reflected ray is really existing. Normal line is not existing. It's imaginary. You use dotted line. So can I draw the normal line like this? Can I draw it like that? No, I can't use a solid line for the normal line. You should use dotted line because it's an imaginary line. So putting everything together, what is normal line? Imaginary line drawn perpendicular to the reflecting surface at the point of incident is normal line. What is normal line? Imaginary line drawn perpendicular to the reflecting surface at the point of incident is normal line. Don't memorize these things. These are points you should understand and keep. Imaginary line perpendicular at the point of incident is normal line. Additionally, there is an angle between the incident ray and normal line. Angle between incident ray and normal line is called angle of incidence. Angle of incidence. Or even you can call it incident angle, symbolized by simple I. No capital I, simple I. So simple I is angle of incident, that is the angle between the incident ray and the normal line. Angle between incident ray and normal. Next, the angle between reflected ray and the normal line. Reflected ray and the normal line is called angle of reflection. Angle of reflection, or even you can call it the reflected angle. It's the reflected angle. So I is angle of incidence, that's the angle between incident ray and the normal line. R is the angle of reflection. It's the angle between reflected ray and the normal. Those are the important points you need to know about reflection. Sorry. If you have any doubts, at the end I'll give a time. At that time you ask. During the explanation, don't interrupt and ask doubts. So these are the important things about reflection. Go to the tube. Reflection of light. Reflection in plane mirror. Under that a box is given. I want you all to draw the reflection in that box. Now ask the doubts.
Will reflection take place only in smooth surface?
Even yeah, only in smooth surface. In rough surface, a reflection called irregular reflection will take place. In smooth surface only normally reflection take place.
Thank you, sir.
Okay, welcome. Draw it once done, tell me done. Right? Yabuda. Yabuda. Yes, someone excused me.
Sir,
Yeah.
sir, if I want to take recording of frequency, sir, I have to additional option for
Natasha, you are not audible. Natasha, you are not audible properly.
Sir, will reflection take place at convergent beam or divergent principle?
Hmm? You can't tell that anywhere when light ray comes, reflection will take place.
the done, sir. Done, sir.
Okay.
Done, sir. Done, sir. Done, sir.
And did you all write I is equal to angle of incidence or incident angle, R is equal to angle of reflection or reflected angle?
Yes, sir.
Yes, sir.
Sir.
Okay, enough time. In case if you're still writing, take a screenshot and keep. Right. Now whatever I explained are given there. Bouncing of light after falling on a smooth surface is reflection. Imaginary line drawn at the point of incident perpendicular to the mirror is normal line. It's the mirror because here the heading is given reflection in plane mirror. Next, the angle between the incident ray and the normal line is known as angle of incidence. The angle between reflected ray and the normal line is known as angle of reflection. Right. Next. Laws of reflection. Laws of reflection. I mean, remember, there are two laws in reflection. We have two laws in reflection. First one is the first law of reflection, and the second one is the second law of reflection. Two laws of reflection, first law of reflection and second law of reflection. First, going to the first law of reflection. What is first law of reflection? First I'll tell the law, then I'll explain. What is first law of reflection? Incident ray, reflected ray, normal line at the point of incident, all are on the same plane. Incident ray, reflected ray, normal line at the point of incidence, all are on the same plane. All are on the same plane. It talks about the same plane. What do you mean by that? Incident ray, reflected ray, normal line, all these three are on the same plane, it seems. Same plane. Now, what do you mean by same plane? What do you mean by a plane? Plane means like a surface. It's like a surface. Now, this smart board is a plane. This is a vertical plane. Now, I have a wall here. The wall there is another plane. I have a wall in front. That is another plane that is parallel to this plane. I have another wall there. That is another plane that is parallel to this plane. I have my floor. Floor is another plane. Those are different planes. Now, if you take a cuboid, in a cuboid, this is one plane, and for that parallel plane is this plane. This is another plane. For that parallel plane is this plane. This is another plane. For that parallel plane is this plane. So those are planes. Those are planes. Those are surfaces. Now, what is the first law of reflection telling? Incident ray, reflected ray, normal line at the point of incident, all are on the same plane, it seems. If incident ray comes in one surface, reflected ray also should go in that same surface. No? Normal line also should be in that same surface. No? Now, can the reflection take place like this? Let's take incident ray is coming like this, knocks, reflected ray is coming like this. Can that happen? Again, I will show. See, incident ray like this, reflected ray like this. Can that happen? No. If incident ray comes in this surface, reflected ray also should go in that same surface. Someone's mic is on. If incident ray comes in this surface, reflected ray also should go in that same surface. Incident ray can't come in this surface and reflected ray can't go in that surface. And normal line also should be drawn in the same surface. Harine, I drew incident ray, reflected ray, normal line all on this smartboard surface. You drew incident ray, reflected ray, normal line all on that same A4 paper. Did you draw incident ray in one A4, reflected ray in another A4 in another direction in another plane? No. So that's the first law of reflection telling us. So in one more time, what is first law of reflection telling us? Incident ray, reflected ray, normal line at the point of incident, all are on the same plane. Go repeat with me, open the mouth and tell louder and repeat with me. Incident ray, reflected ray, normal line at the point of incident, all are on the same plane. Okay? Let's write down. Take laws of reflection. First law of reflection. Write down, right there. Incident ray, comma, reflected ray, comma, normal line at the point of incident, 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 all are on the same plane. All are on the same plane. All are on the same plane. All on the same plane. Sorry, should I repeat again? One more time I'll repeat, see whether you wrote the correct sentence. Incident ray, comma, reflected ray, comma, normal line at the point of incident, all are on the same plane. Sorry, that's the first law of reflection. Next, second law of reflection. Second law of reflection is very easy, very simple. What is second law of reflection telling us? What is second law of reflection telling us? Angle of incident I and angle of reflection R both are equal. Angle of incident, angle of reflection, both are equal. Angle of incident is equal to the angle of reflection. That means this angle and this angle both are equal. If I is 30 degrees, R also is going to be 30 degrees. If I is 60 degrees, R is also going to be 60 degrees. I and R are equal. Alright? Write down. Under the second law of reflection, angle of incidence, angle of incidence and angle of reflection are equal. And then write down I is equal to R and box it. I equal R, box it. I equal R, box it. Right. Using that logic, do some questions with me. First one, simple question. A light ray is coming, light ray is going. We'll take I as 40 degrees. My question is, what is the value of R? Simple question. Second question. light ray coming, light ray going. That is 50 degrees. What is the value of I? Third question. Quickly draw with me in your writing book. That is 25 degrees. Question is, what is the I value and what is the R value? 1 minute, quickly work. And if you can send me the answers, don't unmute and tell, send me the answers. Right. What's your answer? First one, very simple. I is 40. Incident is 4. I didn't mark the arrows. Hope you all mark the arrows. I is 40. Incident is 40. If I is 40, then guaranteed we can tell R is also how much? 40. If I is 40, automatically R is also 40. I is 40 now, R is also 40. So here the R value is 40 degrees. Second one, R is given now. R is 50. If R is 50, automatically we can tell I is also how much? I is also 50. I is 50. I is 50. Last one. Last one is tricky. So you all talk to me. You all tell me, this is 25. I have not defined this angle anywhere. That value is given 25. If that is 25, tell me what is my I value first of all. 65. How do we get 65? Normal line and the reflecting surface are perpendicular. If they are perpendicular, the total should be 90. If total is 90, this is 25. Now this is going to be 65. So I value is going to be 65 there. I value is 65. If I is 65, automatically we can tell R is also 65 degrees. Okay. Hope all of you got it. Yes. Right. That is reflection in a plane mirror. That is reflection in a plane mirror. Next. Now, Lamai, if you keep an object in front of the mirror, you will be able to see the image of that object inside the mirror. How do you see the image there? What's the physics behind it? We are going to draw ray diagrams and understand that. We are going to draw ray diagrams and understand how you see an object that is kept in front of the mirror as an image inside the mirror. Right. We'll take this as a plane mirror. That is a plane mirror. In front of the mirror, I'm going to keep an object. Now in our syllabus, we only talk about the image formed by a point object. What do you mean by a point object? A small point. You take a small point and keep it in front of the mirror. How will the image of this point be formed in the mirror? Only that we discuss in our syllabus. We don't discuss about objects with a height under the plane mirror section. We only discuss about point object that is kept in front of a plane mirror. Right? Now let's take, you have a point of, for example, let's say you have a dust. You keep it in front of mirror. How will the image be formed? Onna see, eh? See how I draw this. These are the ray diagrams you need to understand. Right. Now in front of the mirror, there you go, I keep a point object. In geometrical optics, object should be marked as O. Object we mark as O. So that is the object in front of the mirror. Right. Listen, ne? Lamai, to form the image of a point object, minimum we need 2 light rays from that object. Put it in the mind. To form the image of a point object, minimum how many light rays we need from that object? Minimum 2 light rays we need. So what I'm going to do is, I keep the object like that and I'm going to take 2 light rays from that object. I keep the ruler, just draw 1 light ray. That is 1 light ray. A light ray is coming from that object and striking on the plane mirror. Now you all tell me, when a light ray falls on the plane mirror, what will happen to that light ray? It will reflect, right? We already have learned all the theories that are needed for reflection. We have already learned about reflection. Now it is reflecting. So I'm going to first draw the normal line. That is the normal line. So now light is going to reflect. Light reflect. That's the reflected ray. That's the reflected ray. What we know about the incident ray and reflected ray, they have the angle. This is incident angle I, this is reflected angle R. What we can tell about I and R? Both are equal. And that way you drew. If you take this as 30 degrees, this also should be 30 degrees. Right, one light ray drawn. Is one light ray enough for us to draw the final image? No. Minimum how many light rays are needed? 2 light rays. So what I'm going to do is I'm going to draw another light ray. Just keep the ruler and draw a line. That's it. Just randomly draw a line like this. Second light ray. Second light ray is also striking on the plane mirror. That light ray will also reflect. That light ray will also reflect. Before drawing the reflection, I draw the normal line. I draw the normal line. I draw the normal line. There you go. That's the normal line. That's the second light ray. Right. That's the second light ray. So 2 light rays are drawn. This is the angle of incidence of the second light ray. This is the angle of reflection of the second light ray. We already know I and R should be equal. For example, if I is 60 degrees now, R also should be 60 degrees. Right. 2 light rays are drawn. Now, where is the image going to be formed? How are you going to find the place where image is formed? Onna listen, last step. After drawing this, you keep a ruler on the reflected ray. You keep a ruler on the reflected ray, that is this ray, and extend the ray backwards. Extend the ray backwards. You extend it backwards. The first light ray is extended backwards. Now, when you are extending, are you going to use solid ray, solid lines, or you are going to use dotted line? Think according to the logic I taught you previously and tell me. Why dotted line? It is really existing, then nothing imaginary. Imaginary. It's not really, the light ray is not going inside the mirror. No, this is something we are imagining and we are extending it. Right. So that is one reflected ray. I extended it backwards. Second reflected ray also you extend it backwards. Keep the ruler and you extend it. When you extend both these light rays backwards, at a certain point, both these light rays will meet. See, both are meeting. Both will surely meet. And if you take the angles properly, 30, 30, 60, 60, like that, if you take the angles properly and draw, surely both the light rays will meet. That meeting point is the place where your final image is formed. So this is the object in front of the mirror. This is the final image. So if I look at that image using my beautiful eyes here, I can see that image somewhere there. That's the object, that's the image. Again, see how did I draw this? First I get the object, a point object in front. To form the image of a point object, minimum I need 2 light rays. I draw one light ray, reflected it. I should make sure that I value and R value are equal. So I reflect and take. Second light ray, reflect and take. I and R should be equal. Extend the reflected ray, both will meet. Right? Now you'll ask me, sir, in case if we get to draw this in the exam, should we really measure these angles? And draw? No need. If you carefully observed how I drew this, I used a tricky method. How did I draw? Did you all see? After drawing the incident ray, I didn't draw the reflected ray. I drew the dotted line and drew it. Can you remember how I drew that? I drew the dotted line, extend it. I drew the dotted line, extend it. Then surely there will be a meeting point. That way I brought the meeting point. Got it? So that way you can use to draw. When you draw like that, automatically I value, R value become equal. Got it? Now what are the properties of this image? What are the properties of this image? This image is going to be a virtual image. What kind of image? Virtual image. Ani sir, what is virtual image? I will explain. In few minutes I will explain. For now just memorize and keep. The image formed by a plane mirror is a virtual image. I will explain about it. Number 2, it is a upright image. It's a upright image. What do you mean by upright image? Now think about a mirror. You go stand in front of the mirror. This is you. When you stand in front of the mirror, your same upright image will be formed inside the mirror as well, no lame? Will it form a inverted image? You go stand in front of the mirror. Your head will align with the head there. Will your head align with the leg there? No. That is upright image. This is upright image. Object image. If the image is like this, this is an inverted image. This is an inverted image. So tell me, in a plane mirror, what kind of image will be formed when you go look at your face through the plane mirror? What kind of image? Upright image. So it's an upright image form. Next, you measure the distance between object and the mirror. Distance between object and the mirror is called the object distance. Distance between object and the mirror is object distance. And you measure the distance between image and the mirror. Distance between image and the mirror is called image distance. When you measure both those distances, remember, both those distances will be equal. Which means if this is 10 centimeter, this also will be 10 centimeter. So object distance I write as OD, object distance, and image distance I write as ID. Both are going to be equal. Next, the image form will be an identical image. Harine lamai, you go stand in front of the mirror. Your image only will be formed in the mirror. No? When you go stand in front of the mirror, will your sister's image be formed there? Or will your brother's image be formed there? No. Your same identical image is only formed inside the mirror. No? Image will be identical. Now with that, we tell another point as well. What I mean by identical is not only it's same, even the size is same. When you go stand in front of the mirror, your same size image will be formed there. Now when you go stand in front of the mirror, will you become a Hulk inside the mirror? Or will you become a thin fellow inside the mirror? Your same size, your same view will be formed there. That is identical image. So images formed by plane mirrors are identical image. Finally, the image formed by plane mirror will be laterally inverted. What is laterally inverted? I will explain. This lateral inversion and virtual image I will explain. Don't worry about that. Those two for now memorize. Within another 10 minutes you will understand that. Tell me, what are the properties of the image formed by a plane mirror? Image is a virtual image, upright image, object distance, image distance are equal. It's an identical image. What do you mean by identical image? Size is same, laterally inverted. Go open the mouth and tell what are the properties of the image formed by plane mirror? Virtual image, upright image, object distance and image distances are equal. The image is an identical image, that means size is same, laterally inverted. One more time, open the mouth and tell. Virtual image, upright image, object distance, image distances are equal. It's an identical image, laterally inverted. Now, what is virtual image? Onna listen, ne? Images. There are two types of images. One real image, and two virtual image. Anisha, what is real image? If an image can be taken to a screen, you call it a real image. If an image can be taken to a screen, you can take it to a screen, now you call it a real image. Then what is virtual image? If an image cannot be taken to a screen, now virtual image. Can be taken to a screen, real image, cannot be taken to a screen, virtual image. Now what is that? Now what is screen, first of all? Screen is maybe a white wall, or a white paper, or a white cloth. That is a screen. If you can project the image on a screen, if you can take the image to a screen, it is real. If you can project the image to the screen, that image is really existing. It's a real image. If you can't project it to a screen, if you can't take it to a screen, it is a virtual image. Now, for example, think about the image formed by a projector. We project the image to a screen. That image is really existing in our real world. Now you put the projector, you can go stand in front of the projector. Those images will be formed even on your body. Why? Because it's a real image. That image is really existing in our world. You can touch that image. First time when you see projector, you might be wondering, what are those images? Can we touch those letters? Yes, you can touch those letters. Because those images are really existing. Projector images are real images. But think about image formed by a plane mirror. You go stand in front of the mirror. Your image is formed inside the mirror. Can you touch that image? Can you keep a screen in that image? Go tell me, when you go and stand in front of the mirror, your image is formed. Can you go inside the mirror and keep a screen there and take the image onto the screen there? Can you do that? Yes or no? No. You can't go inside the mirror. Maybe in cartoons they can. There was a Garfield's cartoon where Garfield went inside the mirror. But no, normally we can't go inside the mirror and keep a screen there. You can't take that image to a screen. It is really existing image. Nothing, just a virtual image. It's a virtual image. Understand the meaning of the word virtual. Virtual means not real. Harini. The image formed by a mirror is not real. It's there inside the mirror. You can't touch that image. You can't keep a screen and take that image to a screen. You can't go inside the mirror. No, Lama, inside the mirror you have a different world there. Think like that. That world you can't enter. You can never enter that. Only real world you are existing or you are entering. Virtual world, you can't enter there. You can't keep a screen there. So remember, images formed by a plane mirrors are virtual images. Images formed by projector is a real image. Understood the difference? This is very important. Without this, you can't do this lesson. Okay. Images, if you can take the image to a screen, real. If you can't take the image to a screen, it is virtual. Now projector, you can take the image to a screen, real. It's really existing. But plane mirror, tell me, if you go stand in front of the plane mirror, your image is formed inside the plane mirror. Can you go inside the mirror and keep a screen and take the image to the screen? No, you can't take that image to a screen. That is a virtual image. Understood? Yes. Yes. So remember, real images you can take to a screen. Virtual images you can't take to a screen. Remember, with the example, projector image is real. You can take to the screen. Plane mirror image is virtual. You can't take to a screen. Okay. Ehenang, tell me, this image that we drew, real the virtual? Real the virtual? Virtual image, it's formed inside the mirror. Virtual. And can you see, we are drawing that image using dotted lines. Using dotted lines, are there real light rays there? Is light rays really going there? No. Even we don't have real light rays there. Now in a projector, really light rays come out to form the image. Here, no any real light rays. These are just some imaginary light rays we are drawing. So imaginary light rays are never going to form a real image. Imaginary light rays will form a virtual image. So here a virtual image is formed. Hari? So that is real virtual story. So remember, plane mirror forms a virtual image. Next, what is this lateral? Lateral inversion means? What is lateral inversion? Your left appears in right and your right appears in the left. That is lateral inversion. Now, for example, you go in front of the mirror and show letter B. B will be appearing in this direction. You show letter C. C will be appearing in this direction. Your left turns to the right. Now you write down, I love science. Keep it in front of the mirror. In the mirror, you will see it as science love I. Neither. That is lateral inversion. Left turns to the right, right turns to the left. The full word now, science. If you keep science in front of the mirror, you will see it the other way. How you will see? This is what you will see in the mirror. This is the mirror image. This is the real object. Understood? That is lateral inversion. So remember, in a mirror, this lateral inversion will take place. And we talk about this lateral inversion in a certain instance. What is that? Ambulance. Now, in ambulance, they never print the word ambulance in the correct way. They print it this way. This is how the word ambulance is printed. This is how the word ambulance is printed. Why it is printed like this? Printing mistake. Printing mistake. Why they print it like this? Now, when ambulance is going, now the vehicles in front, they first detect that the ambulance is coming using the siren. The moment someone hears the siren, first what they look? Side, louder. Side mirror. They look at the side mirror. So they are looking at a mirror. In the mirror, what will happen? Lateral inversion take place. So when they look at this one through the mirror, when they look at this one through the mirror, when they look at this, what will happen? It turns to the correct side. So we can see the correct word, ambulance. Right? So that's why it is printed like this. Hurry. Take now. Yeah, okay. You can ask that out.
So what is the opposite word for lateral inversion here, like O?
Now letter O, you're asking letter O, will it show lateral inversion? Is it the question? No, O will undergo lateral inversion, but can you see that? No, you can't see that. You laterally invert letter O. If it is a perfect O. No, not perfect. If it is a perfect O, when I laterally invert it, again I will get that same O. No difference, no. So letters like O, you can't see any lateral inversion. Hurry. So that ray diagram is given. Ray diagram for image formed by a plane mirror. The diagram is given. Image formed is virtual image. Distance from the object to the mirror, that is object distance, is equal to the distance from the image to the mirror. That's the image distance. Next, image formed by plane mirrors are identical to the object. Image is laterally inverted. Important terms: virtual image. Images that can't be projected to a screen are virtual. Real image, image that can be projected to a screen are real image. Lateral inversion. Right side of the object appears as its left side and vice versa. What do you mean by the word vice versa? The opposite. So what's the opposite of this sentence? The left side of the object appears as its right side. So instead of typing that, you can write vice versa. The term ambulance written in front face of the ambulance is inverted. However, when the ambulance is going behind another vehicle, the driver of that vehicle in front sees it through his rear view mirror as ambulance. Okay. Right? Hurry. That's it. Plane mirror section is over. Any doubts from plane mirror section? Any doubts? No, all clear. All clear, no? Hurry, perfect. Now we are moving to the second part under reflection. Still we have not done reflection. We are moving to the second part under reflection. Right. Plane mirrors are done. Next going to curved mirror. Curved mirror. Curved mirror. What is curved mirror? If the surface of the mirror is curved, it's a curved mirror. If the surface of the mirror is curved, you call it a curved mirror. See, if the surface is curved, it's a curved mirror. Most of the time, these curved mirrors are made from a part of a sphere. These curved mirrors are made or obtained from a part of a sphere. Therefore, curved mirrors also can be called as spherical mirrors. Curved mirrors also you can call it spherical mirrors because a part is apart from the sphere is only obtained to make the curved mirrors. Sorry? Now going deeper. Curved mirrors. Lamai, there are two main types of curved mirrors. What are the two main types of curved mirrors? Convex mirror, and uh, concave mirror and concave mirror. Convex mirror and concave mirror. All right, concave first and convex second. Convex mirror, concave mirror. What is concave mirror? What is concave mirror? I will draw and show. It's a curved mirror, which means it has a curved surface. The outer region is rough. So outer region you draw that kata lines. Inner region is the reflecting surface. Inner region is the, there you go, reflecting surface. Inner part is reflecting surface. That is concave. එතකොට convex කියන්නේ the opposite. In convex, inner region is rough. You draw that kata lines. Outer region is the reflecting surface. Outer region is, there you go, reflecting surface. So if the inner surface is reflecting concave, if the outer surface is reflecting convex. How to remember this? I know this is a bit doubtful, a bit confusing. How to remember this? I usually tell the students to memorize like this. Concave. If you look at concave mirror, this is concave mirror. This is concave mirror. If I exaggerate and draw this, this is a concave mirror. Can you see there is a cave there? There is a cave there inside the concave mirror. Three people again. There is a cave there. So if the cave is reflecting concave, if the cave is reflecting concave, even the name has the word cave there. Cave reflecting concave. Cave reflecting now concave, opposite is convex. Memorize it that way. Now don't go to the exam and write cave is reflecting concave, opposite is reflecting concave. Memorize it that way, but how do you define it? If the inner surface is reflecting concave, if the outer surface is reflecting convex. You all memorize it as cave is reflecting concave, bandi part is reflecting convex. Sorry? Right. Now take curved mirrors or spherical mirrors. Mirrors with curved reflecting surfaces are known as curved mirrors. If the curved surface is a part of a sphere, the mirror is known as a spherical mirror. There are two main types of curved mirror. Write the two main types of curved mirror: concave mirror, convex mirror. Write the two types.
Sir,
Yeah.
sir, I wanted that previous person's recording. So I have to pay additional.
Can you message that number I posted at the beginning? Okay. Okay. Right. Under that there is a box given. Unnecessarily a big box is given. You don't need the full box there. In that box I want you to write this. This is what goes in that full box. Draw this in that box. That full box is this. Draw it and tell me done once you are done. Enough time. That's it. Initial things. Now going a bit deeper about curved mirrors. Deeper about curved mirror. I'll first explain about concave mirror, then we can connect it and talk about convex mirror as well. First about concave, then I'll discuss about convex. Listen very carefully now. Concave mirror, right. If you look at a concave mirror, concave mirror is actually a part of a sphere. It's actually a part of a sphere. A sphere you take and cut down a part, that is how you get a concave mirror. You cut down a part of the sphere, that is concave mirror. So concave mirror is actually a part of a sphere. Now in this sphere, I will have a center. That's the center of the sphere. In that sphere, there you go, I have the center. That's the center of the sphere. The center of the sphere is called as, center of the sphere is called as center of curvature. Center of the sphere is called as, there you go, center of curvature. Center of curvature, symbolized as capital C. Center of the sphere is center of curvature, symbolized as capital C. And the mirror will have a center point. Mirror will have a center point. Center point of the mirror is called as the pole, symbolized as capital P. Center of the sphere is center of curvature, symbolized as capital C. Center of the mirror is the pole, symbolized as capital P. Now, I am going to draw a line connecting the pole and center of curvature. I draw a line connecting the pole and center of curvature. That line is called as principal axis. The line connecting the center of curvature and the pole is called as the principal axis. So that is the principal axis. Now, between center of curvature and the pole, at exactly in the middle, I keep a point. Exactly in the middle between center of curvature and the pole, I keep a point. That point is called the focal point. That point is the focal point, or even you can call it the focus, symbolized as capital F. Again listen. Concave mirror. Concave mirror is actually a part of a sphere. In that sphere, you will have a center. Center of the sphere is center of curvature. Center of the mirror is pole. Now, center of curvature and pole, you draw a single line. That single line is the principal axis. You divide the center of curvature and the pole by its center, by its middle. That point is called the focal point, or you can call it the focus. Up to there, clear? Yes?
Yes.
Now, there is a distance between the pole and the focal point. There is a distance between pole and the focal point. That distance is called the focal length. That distance is the focal length, symbolized as simple f. That is focal length, symbolized as simple f. Focal length. Remember the difference, eh? Capital F is focal point, simple F is focal length. Next, there is a distance between center of curvature and the pole. A distance between center of curvature and the pole. That distance is called as radius of curvature. Radius of curvature, symbolized as simple R. Radius of curvature, symbolized as simple R. Radius of, there you go, curvature. Okay. if you have understood everything, y'all tell me a relationship between radius of curvature and focal length. Tell me a relationship between radius of curvature and focal length. What we can tell?
Focal length is the twice of the radius of
Anna Hari. Perfect, Pota.
radius.
Radius of curvature is twice the length of focal length. Radius of curvature is twice the length of the focal length. Hari Nilamai, I told you focal point is exactly in the middle, which means focal length and radius curvature, the relationship is radius of curvature is twice the focal length. Twice the focal length. Twice the focal length. Radius of curvature is twice the focal length, which means R is equal to 2 times F. R equal to F. Clear? These are the initial definition. Later on, the definition for focal point, focal length, radius of curvature, those definitions will slightly change. Later, I will change those definitions. Now, these kinds of definitions are the definitions we use. Alright. Now, if you have understood those things, y'all are going to help me for convex mirror. Now, your turn. You are going to help me for, there you go, convex mirror. We can consider convex mirror as a part of a imaginary sphere. We can consider convex mirror as a part of an imaginary sphere. First tell me, in a convex mirror, outer part is reflecting the, inner part is reflecting the, didn't tell me the answers? Reflecting. Outer part is reflecting. Now inner part you draw that kata lines. That's a convex mirror. There will be a center point in this sphere. The center point in the sphere is called the center of curvature, capital C. There will be a center point in the mirror. Center point in the mirror is called the pole. You draw a straight line. You draw a straight line connecting pole and the center of curvature. That line is called the principal axis. You keep a point exactly in between, exactly in the middle of center of curvature and the pole. That point is the focal point. The length between the focal point and the pole is called the focal length, symbolized as simple F. And the distance between the pole and the center of curvature is called the radius of curvature, symbolized as simple R. Got it? Right, perfect. Figure shows that spherical mirrors are part of hypothetical spheres. Those pictures are given. Center of each sphere, C, to which the mirror surface belongs to, is called the center of curvature of the mirror. Center point of the curved mirror is called the pole of the mirror. The line joining the pole and center of curvature is known as principal axis. Principal axis is perpendicular to the mirror surface. What is that? If you look at this principal axis is going to be perpendicular to the mirror surface. Perpendicular means what's the angle there? 90 degrees. So principal axis is perpendicular to the mirror surface. Hari nilamai, mathematically think. You have a circle. This is maths, not science. You have a circle. From center, if I draw a line, first tell me what is that line called as?
Radius.
That is radius. What can we tell about the angle between the radius line and the surface of the circle? 90 degrees. Both are perpendicular. Did you all learn that in maths? Circle theorem? There's a circle theorem where you tell radius line is perpendicular to the surface of the circle. Also you can tell then diameter line is also perpendicular. From that so many theories are made. Now if you draw a triangle from that, you can measure the angles of that triangle. From there here the angle become 90. Use a circle theory in geometry in maths. Hurry. So keep in mind, if you draw a line from the center, that is maybe radius, hurry, diameter, whatever line, hurry, that line makes 90 degrees with the surface of the circle. So here, principal axis is perpendicular, makes 90 degrees with the surface of the mirror. 90 degrees. Someone's mic is on. The distance between the pole and the center of curvature is known as radius of curvature of the spherical mirror. Radius of curvature is exactly twice the focal length. Under that, write that relationship. Radius of curvature is twice the focal length. R is equal to 2F. Hurry. Right. Next, we have two things to learn under each curved mirror. First, we have to learn about their reflection. Second, we have to learn about the images form. What's the ray diagram we can draw to get the images form. So under each section, two things we have to learn. One, their reflection. Two, how the images are formed. Drawing ray diagram for the images form, image formation ray diagram. Under concave mirror, two sections we have to learn. Under convex mirror also, two sections we have to learn. We'll start with the first one. Concave mirror. Concave mirror. We are going to learn about the reflection in concave mirror. Onna listen very, very carefully. Reflection in concave mirror. First, if you send parallel light ray to a concave mirror, what will happen? Onna listen, ne? Parallel light ray. Onnalama, you have a concave mirror. What is concave mirror? Cave part is the reflecting surface, outer part you draw the kata lines, right? Then you draw the principal axis. This is your principal axis. Remember, whenever you draw any ray diagrams in curved mirror, near the mirror surface, draw a dotted line. There is no any name given to this dotted line, but this dotted line is very, very important. Very important dotted line. Why? Later I will tell. Whenever when you draw in a ray diagram, near the mirror surface, draw a dotted line. Plus, that dotted line should be perpendicular to the principal axis. And it should go through the mirror surface. That way you draw a dotted line, exactly the way I have drawn. That way you draw a dotted line, right? There's no any name, no any name to this dotted line, right? Now what I'm going to do, I'm going to send parallel light rays to this mirror and see what is going to happen, right? This is the focal point, twice of the focal point is the center of curvature, right? I send a parallel light ray. What do you mean by parallel light ray? This is parallel light ray. Can you see this light ray is parallel to the principal axis? That's a parallel light ray. When you send a parallel light ray to the mirror, concave mirror, what will happen? That parallel light ray will reflect and go through the focal point. Parallel light ray reflect and go through the focal point. Parallel light ray reflect and go through the focal point. So remember, when you send parallel light ray to a concave mirror, it will reflect and go through focal. And now, try to understand the use of this dotted line. Why am I using this dotted line? Can you see, I am drawing the reflection on the dotted line. Did I draw it on the mirror surface? No. Did I bounce it on the mirror surface? No. Reflection is done on this dotted line. It is very important. Remember, in ray diagram, in curved mirror ray diagrams, we never do the reflection on the surface of the mirror. We do the reflection on the dotted line. Why? Why it is like that? Now, why can't we draw the reflection on the mirror surface? Now, that is what is really happening. Really what is happening is reflection is happening on the mirror surface. Then why are we drawing a dotted line and drawing the reflection on the dotted line? This is the reason. Now, if I ask you all to draw this ray diagram, maybe one fellow will draw the concave mirror like this. So, this is concave mirror. Hariputa, correct. I can't tell no. Another lazy fellow might draw the concave mirror like this. So, this is concave mirror. Yes, correct. I can't tell anything wrong. Both are concave mirror. Now, when I ask them to draw that ray diagram, maybe the first one will draw like this. Maybe the first one will draw like that. Maybe the second one will draw like this. Second one will draw like this. And when you draw like this, can you see there is a difference in the ray diagrams here? Reflection, there is a difference there. Why? Our curves in the mirrors are different. As the curves in the mirrors are different, there is a difference in the way they have drawn it. Is it good? Is it standard? No, that is not standard. This is not standard ray diagram. Therefore, what we do, whatever the way you want, you draw your mirror. Doesn't matter. Whatever the way you want, you draw your mirror. We don't care about it. We basically don't care about the mirror. If you want, you draw it like this. Doesn't matter. If you want, you draw it like this. That also doesn't matter. Whatever the way you want, you draw the mirror. Doesn't matter. But when drawing the ray diagram, you draw a dotted line with the mirror. Now do the reflection on the dotted line. Do the reflection on the dotted line. On the dotted line. Here also, you draw a dotted line. You draw a dotted line. There you go. You draw a dotted line. And you do the reflection. And you do the reflection on the dotted line. On the dotted line. When you do like this, is there any difference? No. Now, even if you remove the mirror, can you say both the diagrams are 100% like similar? So to maintain this standard, what we do, whatever the way we want, we draw the mirror. Doesn't matter. But we draw a dotted line. We do all the reflections on that dotted line. Okay, so keep in mind, mirror is not a big thing. Whatever the way you want, you can draw the mirror. Doesn't matter. What is most important here is the dotted line. Dotted line is given the biggest priority compared to the mirror. Okay. So first one, when light rays are coming parallel, it reflect and go through the focal. Now I am going to do it in the opposite way. Now I am going to do it in the opposite way. Second, now I am going to send light ray through the focal. I am going to send light ray through focal. We'll see what is going to happen. I am going to draw the ray diagram. Now I am going to draw it in a little different way. You all tell me, do we prioritize the mirror? No. What we prioritize here? The dotted line. Right. So I am going to prioritize the dotted line. First I am going to draw the mirror. First I am going to draw the dotted line. Mirror, not a priority. Just for the sake of drawing the mirror, I am going to draw the mirror and keep. Just for the sake of drawing mirror, I draw the mirror and keep. Let's take this is F. This is center of curvature. Now you should make sure that the distances are properly measured. If this is 5 centimeter, this also should be 5 centimeter. That way you measure. Now I am going to send the light ray. I am going to send the light ray through the focal. I send the light ray through the focal. Now think and answer me. When you send light ray through the focal, now what will happen? First one, parallel light ray went through focal. Parallel went through focal. Now think and tell. If a light ray comes through focal, it goes? It goes parallel. The opposite. Nothing to memorize. Parallel goes through focal. Focal goes parallel. Parallel goes through focal. Focal goes parallel. And you should do the reflection where? On the mirror surface, nothing on the dotted line. On the dotted line. So second one, light ray coming through focal goes parallel. Third one. If a light ray comes through center of curvature. If a light ray comes through center of curvature. Now what is going to happen? On the principal axis, That is the dotted line. I'm not interested about the mirror. Just for the sake of drawing the mirror, I draw the mirror and keep. That is focal. That is center of curvature. Now I send a light ray through the center of curvature. Through the center of curvature. When I send a light ray through the center of curvature, what will happen? It will reflect and again go through the same path. That means if a light ray comes to center of curvature, again it will go through center of curvature. C goes through C. Second, tell me the first three. Light ray coming parallel goes through focal. Second, light ray through focal goes parallel. Third, light ray coming through center of curvature, reflect and again go through center of curvature. Fourth is actually a continuous version of the third one. Continuous version of the third one. For the fourth one telling, if a light ray comes along, principal axis, what is going to happen? If a light ray comes along the principal axis, I'm going to send a light ray through principal axis. Lamai, when a light ray comes along the principal axis, it will reflect and again go through principal axis. Light ray coming through principal axis, reflect and again go through principal axis. Hari ne lamai. Look at the third one. What is third one telling? If a light ray comes along center of curvature, again it will go through center of curvature. Now look at this one. Light rays coming through principal axis means actually the light ray is coming through center of curvature, right? If a light ray comes along center of curvature, it will again return through the same path. Again it will go through that center of curvature. Now that means again it will go through the principal axis. Hurry. Last one. Fifth one. Or the last one. If a light ray comes, making a certain angle with the principal axis. If a light ray comes making a certain angle with the principal axis, it will reflect and again go, making that same angle. If it comes with 30 degrees angle, again it will go with 30 degrees angle. If the light ray comes with 60 degrees angle, again it will go through 60 degrees angle. So if the light ray comes with a certain angle, it will reflect and again go with that same angle. Hurry. Again one more time, tell me all this. Tell with me, yeah? Light ray coming parallel, reflect and go through focal. Light ray through focal, reflect and goes parallel. Light ray through center of curvature, again goes in the center of curvature. Light ray coming through principal axis, again goes through principal axis. Last one, if a light ray comes making a certain angle with the principal axis, it goes again making that same angle. Again one more time, put these things into the mind. Light ray coming parallel goes through focal. Light ray coming through focal, again goes parallel. Light ray coming through center of curvature, again goes through center of curvature. Light ray coming through principal axis, again goes through principal axis. Light ray coming with the angle goes with that same angle. Okay, clear? What I mean by clear is the things in your brain. That's the meaning when I ask, is it clear? Yes? Yes. Hurry.
Yes, sir.
Hurry. What is the dude? Reflection from concave mirror. First one. Rays coming parallel to the principal axis pass through the focal point after being reflected. Parallel goes through focal. Second one. Rays coming towards the concave mirror through focal point are reflected parallel. Focal goes parallel. Rays coming towards the concave mirror through center of curvature are reflected back through the center of curvature. Next, rays coming along the principal axis of concave mirror return along the principal axis. Finally, rays making a certain angle of incidence with the principal axis are reflected back with an equal angle of reflection. This means I is equal to R. If it comes like that, it goes like that. Hurry. I'll give you all 1 minute. Again, put all these things into the mind before going to the next section. Okay. Now, for you all, already previous batch has finished their exams. They are 100% free. They are free in the sense now they haven't started the A levels. So, whole spotlight is on y'all. Right? Next turn is on y'all. Now, y'all are the batch. There's no more. Already there's a batch. No. Now the spotlight is on y'all. Most of the time your exams will come in December, most of the time, right? If it goes to January, it's a bonus for you. If it goes to January, think like it's a bonus, but don't target for the January. You target for the December and work. Think like on December 9th, December 2nd, you will have the exam. Think like that. Even don't take December into your account. So leaving December, we have March, April, May, June, July, August, September, October, November. 9 months are there. Only 9 months are there. 9 months, 9 subjects, which basically means you have only 1 month for one subject. That's the truth, no? Just think. You have 9 months for 9 subjects. Additionally, if the exam goes to January, then December, additional 1 month bonus is there. We'll keep the bonus month aside. So 9 months for 9 subject means 1 month for the one subject. For one subject, one full subject, you have only 1 month. Now, for example, if you take science, there are 35 lessons altogether in science. Grade 10, 20 lessons, grade 11, 15 lessons, altogether 35 lessons. For all those 35 lessons, you have 1 month to finish. In that 1 month, you have to finish the theory, plus the revision, plus the past paper. Which means now you have come to that stage where you have to utilize your time to the maximum. That's the stage. Now you have to start utilizing your time to the maximum. You can't waste the time when you are in the class. What do you mean by waste the time when you are in the class? In the class, when a teacher is teaching, you listen, put the things to the mind, put it to the brain and go home. Because again, you can't keep time to go home and study it again. It's additional time. It's a wastage time. Now, fifth lesson is going on. Fifth lesson is going on. Can another 10 lessons are there? That means already 25 lessons are done. So you have to revise the 25 lessons plus study the remaining 10 lessons. So don't keep that remaining 10 lessons to again go home and revise. Now it's a wastage time. So in the class, when you're studying, during that time itself, you put the things into the mind. That way you be attentive. Build up that attentive nature at least now. Now whatever you did for the past 25 lessons, hurry, keep it aside. I'm talking about science. Keep it aside. Now you can't do anything. So remaining 10 lessons, when you are studying during the class, put your maximum. In the class itself, solve all your doubts and put everything to the mind and go home. Additionally, at home, what you need to do? The remaining 25 lessons will take now from today. Today, can I? The remaining 25 lessons are there. Remaining 25 lessons, you have to revise for sure. Surely you have to revise. You have to put all those 25 lessons into your mind. Without putting those 25 lessons into your mind, you can't do full papers. So you have to study, you have to revise those 25 lessons. With that, you start doing papers as well. Now start doing past papers. Now, fifth lesson is going on, Kiani. You can do past paper. At least about 70% of the paper you can do. 70 now. Already the previous papers there on 2025 O-level papers there. Start do that. Take it and do that. You can do the MCQs there. MCQs at least about 25 to 27 MCQ. You can do that. So try to do the MCQs there. Now don't wait until all the lessons are over for you to sit and do full papers. No, if you sit like that, no, you don't have time. because all the lessons will be finished keeping about 2 weeks or 3 weeks for the exam. So in three weeks you can't do full papers. So now start doing the papers, start doing the past papers. Get a past paper book with you. Don't tell still I don't have a past paper book with me. No, that's not an excuse you can tell. Have a past paper book with you. Allocate a separate time to do papers, because at the end of the day, lamai, what you are going to do? A paper, no lamai. Just think, 35 lessons. This much 2 years of work finally ends up with what? One single paper. For science, it's a 4-hour paper. 3 hours for the part 2, 1 hour for the part 1. That's it. The 2 years of science journey is over from there. If you're not doing science after that, your 2 years of science journey is over from there. Or you can tell the 11 years of studying journey is over from there. So for that paper only, we are going to work. So at the end, what you are going to do is a paper. So now get ready for the paper. Just sitting and memorizing the things in the book is not enough. I don't tell it is not needed. Yes, it is needed. It is not enough. So you have to study plus do the papers. Do papers as much as possible. Don't start doing unwanted papers. Stick to the syllabus. What will come for the exam? Past papers are the things that can come for the exam. That is our syllabus. Start doing past papers. And if you can, go for provincial papers. If you now, you have the chance of doing 10 years of papers. Until 2016 you can do. Don't go below 2016. It's okay if you are fully done until 2016. It's okay to go below 2016, but below 2016, 2015, 14, they are old syllabus. So stick to the new syllabus. After 2016 until last paper you can do. So do past papers as much as possible. Additionally, do provincial papers. Provincial first term, second term, third term. Best is start now. Now you all are in your second term. Start doing O-level, grade 11 second term paper. If you can, go for third term and mock exam. Most of the time third term mock exam papers are harder than the O-level pass paper. Right? Try to do those questions as well. So now start practicing questions as much as possible, because at the end of the day you are going to do paper. Right? From my end, towards the last days can last 2-3 months again, I will start doing questions. Now if you have observed how we work with the previous batch, you know the amount of work we do. Go through the YouTube channel, you can see how much of work we done for the previous again, or a full question site I will cover in the last few days, last few months. I'll be covering 2.5 months again. Fully will be working every night. So that way I will give the push from my end. But now you have to work from your end. Now you have to push from your end. Alright? So start doing that. Start doing that, because now 5th lesson is going on, which means second term we are going to start the second term. Yes, first term is over. Second term we are going to start. Yes, second term only we are going to start. First term is over. Then papers also you have to do the first term paper, not the second term. First term paper you can start doing. Alright? Right. Reminding this just to tell you that this is the real stage. Still don't keep the work pending. Pending work will only finally end up as a stress. Don't start building stress unnecessarily. Hurry. Right. Now, we know how reflection happens in concave mirror. Reflection part we know. Next, if you keep an object in front of a concave mirror, how will the image be formed? Drawing ray diagram for the image formed by a concave mirror. Drawing ray diagram for image formed by concave mirror. Image formed by concave mirror. Listen very carefully, and this will only come for the exam. Drawing ray diagram for the image formed by concave mirror. Before going to any of the images, first I will teach some important points. These points are very important. Listen, right. Onnalamai, you have a concave mirror. Concave mirror. That is the concave mirror. In front of the concave mirror, that is the focal point. That is the center of curvature. Now, what you do in image formed by concave mirror part? You take a object. What object you take? Not point object. We discuss about point object only in plane mirror. Here we are going to discuss about objects with a height. So you take an object with a height, and you keep it in front of the mirror, and you find out where the image is formed. What are the properties of the image? Properties of the image means whether the image is upright or inverted, whether the image is real or virtual. What can you tell about the size of the image? Those are the properties of image. So you take the object, keep the object in front of the mirror, and you find out where the image is formed and the properties of the image. Now, what kind of object you are going to take? Object with a height. Now, what object we can take? Now you will tell answer, take a human and keep in front. Yes, you can give. Why human have a height? No. You can keep a human if you want. Or if you want, you can keep a candle in front. But drawing these are a bit hard. As drawing these are a bit hard, usually the object that we used to draw ray diagram is a arrow. Arrow is the object that we are going to use, because arrow anybody can draw, it's easy. Arrow is the object we are going to use. So what we are going to do, take this arrow, keep it at different positions and find out where the image is formed and the properties of the image. What are the positions we are going to keep this object? We are going to keep this object at 6 different positions. What are the 6 different positions? Number 1, we keep the object between the mirror and the focal. Number 2, we keep the object at the focal. Number 3, we keep the object between the focal and center of curvature. 4 at center of curvature. 5 slightly away from center of curvature. 6 at infinity. So at 6 different positions we are going to keep this object and find out where the image is formed and the properties of the image. That is what we are going to do. Right. Now, how to draw ray diagram for an object with a height and find out where the image is formed? How to draw ray diagram for this? Right. Listen, Lamai, to find out the image of an object with a height, to find out the image of an object with a height, you need to get some light rays at least from top and from bottom. If you get light rays from top and bottom only, you can draw the image of that object. So to draw the image of an object with a height, at least you need to take some light rays from top and from bottom. Now, for example, take myself. For you to form my image inside your eye, inside the retina, at least there should be some light rays coming from my head, top, and from my leg, bottom. So from head some light rays come, from leg some light rays are coming, head is there, leg is there, a stick is there, sir is there. That way you can form the image. So to form the image of an object with a height, you need some light rays from top and from bottom. For another example, this pen. You need light rays from top and you need light rays from bottom to form its image. Minimum. Actually, there are millions of light rays coming from me, millions of light rays coming from this pen, but minimum you need from top and from bottom. First, I will talk about the bottom. In all the ray diagrams we draw in this section, we place the object on the principal axis. Where do we keep the object? Where do we place the object? On the principal axis. When you keep the object on the principal axis, Lamai, bottom of the object will be on the principal axis. Hari practically thing. When you keep the object on the principal axis, bottom of the object will be on the principal axis. So if any light ray come from bottom, that light ray will be coming along the principal axis. If any light ray come from bottom, that light ray will be coming along the principal axis. It will come along the principal axis. Now y'all tell me, if a light ray comes along principal axis, it will reflect and again go through. It will reflect and again go through the principal axis, which basically means the light ray coming and light ray going from the bottom of the object are always on the principal axis. Is it going anywhere else? No. Light rays from the bottom of the object are always on the principal axis, which means bottom of the image will also be formed on the principal axis. Bottom of the image, that's what we are trying to draw. We are trying to draw the image. Bottom of the image will also be formed on the principal axis, i.e. all the light rays from the bottom are on the principal axis. So bottom of the image will be somehow formed on the principal axis, which basically means we don't need to worry about the bottom of the image. Why? Bottom is always on the principal axis. Wherever you keep the object, bottom is always on the principal axis. Bottom of the object is also on the principal axis. Bottom of the image is also on the principal axis. Now we don't discuss about any objects like this. If the object is like this, is the bottom on the principal axis? No. These kinds of objects we don't discuss. In O levels also we don't discuss. Even in A levels we don't discuss this. These kinds of objects. We only discuss about objects which are on the principal axis. See, on the principal axis. On the principal axis. So always bottom of the object will be on the principal axis, which means we don't need to worry about the bottom. Understood that point? Yes? Right. So we don't need to worry about the bottom. What we need to worry about? We need to worry about the top of the image. That's what we are going to worry about. We don't need to worry about the bottom. We only worry about the top. If we can find where the top of the image is formed, then we can find the final image. That means, let's take, I get the top of the image somewhere there. Top is somewhere there. You all tell me, bottom is always on what? Principal axis. Bottom is on the principal axis. Top is found there. You join them. That is your image. Let's take, I get the top somewhere here. Bottom is always on the principal axis. Join them, that is your image. Let's say you get the top here, margin. Bottom is always on the. Now how to join them? You join them like this. This is top, you get the image. This is what kind of image? Upright image, the inverted image. Maybe inverted image you will get. So in the ray diagrams, what we try to do is, we forget about the bottom. We only worry about the top. We try to find the image, try to find the image of the point of the top. The image point of the top. That's what we try to find by drawing ray diagram. So if we can find the top, we can find the full image. We don't need to worry about the bottom. Next question. How are we going to find the top? Oh, that's the problem. How are we going to find the top of the image? Right, listen. To find the top of the image, we treat the top of the object like a point object. Now, look at this pen. It has a height. Yes, it has a height. Even though it has a height, now only look at the top. Can you see top of this pen is just a point? Top, the topmost part, top is just a point. Top of any object is just a single point. Top of this arrow is a single point, a single dot. Top of any object is going to be a one single point. So what we do is, we treat the top of this object like a point. We treat the top of this object like a point object. You all tell me how to draw ray diagram for point object. Can remember today we started with that. To find the top of the image, to find the image of a point object, minimum how many light rays we need from that point? We need 2 light rays. That's what we started with. To find the image of a point object, minimum we need 2 light rays. So we treat the top of this image, top of this object like a point object. So to find the image of the top, we need 2 light rays from this point. If we can get 2 light rays from the top point, we can find the top of the image. From that we can find the image. Usually the 2 light rays that we obtain is, one, we take a light ray parallel to the principal axis. Second, we take a light ray through the center of curvature. So you all tell me, if you take a light ray parallel to the principal axis, it will reflect and go through what? focal point. If you take a light ray through center of curvature, it will reflect and again go through center of curvature. Usually this is what we do. That doesn't mean always you are going to use only these two light rays. No, any two light rays you can use. Usually these two only we use, but you can change it. At some instances we change. I will tell about it later. But usually these are the two light rays we use. So what we are going to actually do is, see, I'll draw it and show. First you need the dotted line. One light ray I am going to take parallel. From top I take one light ray parallel. From top one light ray parallel. On from top one light ray parallel. You all tell me, parallel light ray reflect and go through what? Focal. It reflect and go through focal, so I reflect and take it through the focal. I reflect and take it through the focal. Second light ray I am going to take through center of curvature. This is center of curvature, this is the top. Both of them I connect and I take. A light ray coming through center of curvature. A light ray coming through center of curvature. A light ray coming through center of curvature. Will reflect and again go through center of curvature. So it will reflect and again go through center of curvature, and there will be a point where both these reflected light rays meet. Can you see there's a point where both these reflected light rays are meeting? That is the point where top of the image is formed. So we know the top of the image. Go tell me, where is bottom? Bottom is on the principal axis. Now you join both of them, you get the image. This is what kind of image? Inverted image. That's the logic behind drawing ray diagrams in this lesson. Again, I'll repeat all these points. See, here you keep the object at 6 different positions and you find out where the image is formed and the properties of the image. In all the positions, you keep the object on the principal axis, which means bottom is on the principal axis. If the bottom is on the principal axis, do we need to worry about the bottom? No, we don't need to worry about the bottom. Why? Because bottom of the image also will be formed on the principal axis. We need to only worry about the top. We treat the top of the object like a point object. To find the image of a point object, minimum how many light rays we need? 2 light rays. Usually we take one light ray parallel, it goes through focal. Second light ray through center of curvature, it again goes through center of curvature. Usually these are the two we take. That doesn't mean always we have to take only this. So we take two, both of them we reflect. Reflected rays will meet at a single point, meet at a certain point. That meeting point only top of the image is formed. Bottom is always on the principal axis. You join them, you get the final image. Okay, clear with that? Yes. And properties of the image, we have to define whether it is a upright or an inverted image. What is upright, what is inverted? These points I'll just give you all. Let's take this is the object. If the object is in the same side of the, if the image is in the same side of the object, that is upright. If the image is in the other side of the object, it is inverted. So this is an inverted image. And this is a real image, the virtual image. A bit hard to find neither. For that, I'll teach a shortcut. Use this shortcut to find whether the image is real or virtual. And you use this only for curved mirrors. Don't use for lenses. Next, we are going to learn about lenses. For lenses, don't use it. Only for curved mirror, you use it. Only for curved mirror, both concave and convex mirror. If the object and the image are in the same side, it's a real image. If the object and image in the same side, real image. If the object is in one side and image is on the other side, image is on the other side, it's a virtual image. Again I repeat, object image same side, real. Object one side, image another side, virtual. Ehenang tell me, now confirm and tell me. Object is here, image is there, real the virtual the. The image is also there. Can what kind of image? This is a real image. Why? Object image in the same side. In case if you get the image this side, then that is what? That's a virtual image. That's a virtual image, right? So keep that shortcut in your mind. Object image in the same side real, object one side, image another side.
Done, sir.
Okay, no?